Find the unit digit of 19 raised to the power x plus 27 raised to the power y. So there are quickly two rules that I want to state, and the rule number one is that while calculating the unit digit, only unit digit of the number matters. That means 9 to the power x will have the same unit digit as 9 to the power x or 29 raised to the power x or 789 raised to the power x. That means while we are calculating the unit digit, any digit other than the unit digit just simply does not matter. Which means the question stem can be converted into the unit digit of this number will be same as the unit digit of 9 to the power x plus 7 to the power y. Now the rule number 2. Rule number 2 is the rule about the cyclicity. Cyclicity is a principle which tells us that the unit digits are always cyclic, which means they repeat after several powers. For example, if you check the cyclicity of 9, then the unit digit of 9 repeats after every second power. For example, 9 to the power 1 is 9, 9 square is 81, so 1, 9 to the power 3 is 729, so 9 again. So you can see that after 2 powers, the unit digit of 9 has started repeating. The similar cyclicity can be observed in case of 7 as well, because 7 to the power 1 is 7, 7 square is 49, so 9, 7 cube is 243, so 3, 7 to the power 4 is 2401. So that way you can see, and 7 to the power 5 will once again have unit digit 7, so the cyclicity here is 4. After every fourth power, the unit digit repeats. So these are two rules that we are going to use. We understand that the cyclicity of 9 is 2, and while the cyclicity of 7 is 4. Now let's quickly check these statements. The first statement says that the product of integers x and y is an odd prime number. So the first information here is that x and y are integers, and second is their product is odd prime number. The prime numbers have exactly two distinct factors. First is 1, second the number itself, and prime number can be written only as a product of two numbers, 1 and the number itself, which means x into y, because it's equal to an odd prime number, so we understand that one of them definitely has to be 1 and other one of them has to be an odd prime number. So there are various possibilities. For example, we can take case number 1 where x is equal to 1 and y is equal to 3. On the other hand, we can take another possibility in which case number 2 where x is equal to 3 and y is equal to 1. In the first case, 9 to the power 1 plus 7 to the power 3 will have the unit digit 9 plus 3, that is equal to 2. In the second case, 9 to the power 3 plus 7 to the power 1 will have unit digit 9 plus 7, that is 6. Different answers, therefore we can prove that the first statement is definitely not sufficient to answer the question. And here, out of the 5 choices A, B, C, D, E, we can eliminate option A and option D. Now let's quickly check second statement. The second statement simply says that x is greater than y, so there are many possibilities. Keeping y equal to 1, x could be 3, x could be 4, x could be 5, leading to the different conclusion, because x equal to 3 will leave us different unit digit of 9 to the power 3 than 9 to the power 4. So the second statement is definitely not sufficient. After we combine the two statements, now we can quickly understand that combination of the two statements confirms that y has to be 1, because the product of two numbers is odd prime and one of them is definitely 1. So the smaller one of them should be 1, so y must be 1. And in that case, x must be either 3 or 5 or 7 or 11 or 13, etc. Now here many of us start thinking that this statement is not sufficient, but it's very important in data sufficiency to back your result what you are claiming. For example, if we say it is not sufficient, we should be able to prove that. Let's check one case, which is y equal to 1 and x equal to 3. So that will result in 9 to the power 3 plus 7 to the power 1, which will have the unit digits 9 to the power 3 is unit digit 9, 7 to the power 1 is 7, so the unit digit is 6. If we take x equal to 5, then 9 to the power 5 will also have the unit digit 9, because every odd power of 9 will give us the unit digit 9 and every even power of 9 will give us unit digit 1. And since we know that x is an odd prime number, so 9 to the power has to be odd prime number and 7 to the power has to be 1, so the result will always be 9 plus 7, resulting in the unit digit 6. So even though we do not have a consistent value of x, but the unit digit of 9 to the power 7 plus 7 to the power y is always 6, and since we have a unique answer, so we say that the two statements together are sufficient to answer the question, and answer to the question becomes option C. I hope you enjoyed the explanation. Thank you so much.